Yesterday we did come up with the answer. I think it was the letter D, right?
Yeah.
But one thing I wanted to just mention to you is you don't have to be so great at calculus to get a 5 on the AP Calc exam once again. If you think about the fact that you got negative 0.241 from that integration, and then the 7 minus the 0.241 gave you that correct answer, which is 6.759. Usually, in the ACT and on the AP exam, the wrong answer, like the intermediate wrong answer, is present in the problem, right? So, let's suppose I'm against time here, right? Like, I have no time left. I gotta run through this test real quick. So what I would do as a good test taker is I would say, okay, which one of these numbers here has some relationship with these other 3 numbers over here, right? And I would notice, wait, hold up, 0.241 and 7.241, that sounds a whole lot like we simply took the initial condition and added 0.241 to it. So I would figure, you know what, it's either gotta be A or E, right, as a good test, right? Or A definitely has something to do with this question, right? Now, if you guys remember yesterday, when you actually found the integration, you ended up with negative 0.241. So the answer was not E, it was actually the letter D because it was subtracting the 0.241. But what I'm trying to explain to you is, if you're caught up on time, or if you're just trying to figure things out, usually they have 2 versions of the answer. They have the intermediate part of it, and then they have the final part of it, okay? And then finally, it's unfortunate when you understand the whole topic and you make one mistake and then they dock you for it by basically you circling the wrong answer, which you thought was the correct answer there. Okay, let's try another one. Okay, so you'll need your calculators today. This is one of the newer problems that they have out there. As you're working with this, again, just a reminder, the word antiderivative is another word for integration of. Okay, so antiderivative is an integral of. Make sure you have radians when you're doing these things. Alright, what did you, what did you guys get? You got the answer B?
Yeah, B.
Alright, very good. Really quickly, this word antiderivative can be a bit of a confusing point for a lot of students. Yesterday, the question that I did was a little bit more straightforward. They actually gave you something that read h derivative. I keep telling you this, and I want you to realize that when they said h of x is an antiderivative of that thing right there, what they're really trying to say to you is h derivative of x is equal to x cubed plus sine x over x squared plus 2. It's just another way of saying the same thing. I would argue it's the more confusing way of saying it. If they just stated the facts like that, we would know what to do right away. So whenever they do that, that's another indicator that they're actually trying to help you get to the FTC question, okay? Again, remember in the new AP, there's only 4 choices. I have to sort of know this part to see if there was a way to play with the answers. What did you get for the integration from 5 to 2?
9.008.
Negative 9.008.
9.008.
Positive?
Negative.
Oh, sorry.
You
Negative.
said-
I flipped it to negative. I flipped 2.
Was you made a minus and put 2 in it? Okay, so you have this, and this was not the correct answer, right? So again, you see what I mean? They usually put the wrong answer, or like the intermediate answer somewhere in there. So then to realize that if you add pi to that, you actually get to the correct answer. And what did you guys said the letter of the answer was what? B? Yeah, so I see that happening. I was just curious where they got these numbers from.
Like if you did pi
If you
minus
took-
negative.
If you took a positive and then you added pi to that, that's
Yeah.
what you did. That's right.
I don't know what the fourth called.
Yeah, I mean, they still throw in sometimes answer choices. It doesn't make a whole lot of sense. But Ken, if you want to be a really good test taker, whether it be in math or in science or any other like reading, like after the test is done, get into the habit of looking at the wrong answer choices and being like, what were they thinking when they wrote it? So then it makes you pretty unbeatable at these things over here. Like that's how kids get perfect scores. That's how I got kind of pretty good scores. Okay. All right, let's go again. Still a calculator question. Any questions so far? So again, this is the third, it took me a lot of effort to find these questions. This is a third approach to the same problem, right? Don't wildly guess on this. But this time it says G is an antiderivative of H. So they introduced some new function and they call that h. So all you need to understand is when they say g is an antiderivative of h, that technically means, right, again, some of you might not realize this right now, that technically means that g derivative is equal to h, right? So if they give you the function h, that's the thing that should go into that pocket, because if you take something's derivative and you integrate it, that's the only way you can actually get to its function value. So now we've done like 3 or 4 questions, and yes, they use the FTC, but they keep presenting it to you in like different sorts of ways. So get used to all of the ways that they've done this in the past. All right, I have a few more of these, and then we'll switch gears to the more difficult fundamental theorem. This is the easier version of the FTC. This is before it's reformed and revised and written. This is not writing anywhere here that you're supposed to use the FTC, so it's all in the units. You have to focus on the units really well. So if you look at what R of T is measured in, it's measured in ounces per minute. Now, technically what that means is this is already a rate. And if they're asking you for something that is simply a quantity, that means you must be going back the other way, right? You must have to integrate something in order to get to the quantity of that something. And so I explained this to you on a different day, and I'm going to explain this to you again because I know this takes a while for people to be convinced that this is true. If you look at the units of R of T, it's in ounces per minute. And dt, what would that technically be measured in? What is time measured in this problem? No, it's minutes, right? You're so used to physics. So this is minutes. Now what happens to the dimensions of these two? They cancel out, right? The minutes cancel out. So then what ends up happening is this goes away with that one, and so you end up with ounces, and that's what they're looking for. They're looking for how many ounces are going to be contained within this vessel over the 3 minutes. Okay, so what did you guys get as an answer? 7.429. Okay, so that's how much ounces there are of honey in whatever the thing is being poured into. We'll come back to this problem again much later in the course, somewhere maybe in March, and it's called flow rates. Okay, so this is a bigger topic. I think you guys will find it very interesting how flow rates work. Go ahead. So if you're counting as I am, this is like the 5th way of asking the same question, right? Read it very carefully. So take a look at this was ounces per minute. They're using a different rate. What is the rate measured in, you guys? Bacteria per hour. So it's a science thing. Scientists need calculus all the same. So you know that if they're giving me a rate and they're asking me about a quantity, the only way this can happen is you need to go back the other way. You need to integrate something, right? That's for sure. So anything that doesn't have an integral symbol, you probably want to leave that thought alone, right? And I mean, look at these answer choices. Like, you don't even need to know much calculus to figure this out. Technically, you have 3 minutes to answer one question like this. So really what you're doing is you're trying to find the amount of bacteria in this container at time 3. They did not give that a variable. Be very careful of that. If you're thinking, isn't that the R of 3? It's not the R of 3. R is actually a rate. So to say R of 3 means the rate at which the bacteria is being put into it, and that's not what we're looking for. We're actually looking for the number of bacteria, i.e. we're looking for a quantity. So if you asked me, well, can you set it up the same way that you set up these equations, I would tell you I can't, because I don't have a name for the notation that you're actually supposed to be on the original quantity of. So here is a technique that a lot of teachers use. Make sure you write this down. They define a variable. I'm sure with Mr. Arnie, when you guys were in statistics, he would make this a really big deal. I technically don't. But what you do is, let's make up a variable. Okay, you can think of any letter that you want, and you could say, okay, how about let's call it Q. So you could say, let Q of T be, make sure you guys are writing this down, because eventually this becomes a free response exercise, be the amount of bacteria in the container. You could also say number of bacteria, because that's the word that they're using. So then, here's what happens. They want the amount of bacteria at time 3, so you would say that's equal to the amount of bacteria that I initially had, plus the integration from 0 to 3 of the rate at which the bacteria was moving in. So then that's how it would actually make sense. Now, what did they tell you initially? How much bacteria was there when they began this whole process? 1,000. Okay, so then the most sensible answer choice would be what then? The letter D. Okay. Any questions? All right. Now, we've heard about average value, and we've also worked with average rate. One of the problems as you start with calculus is just understanding what's going on. And then just when you start understanding what's going on, we decide we're going to go back the other way. So then you thought you understood it, and then suddenly it seems like your understanding is a little shaky, right? So what I tend to do is especially in the second part of this course, I tend to bring in those points of confusion that bother a lot of students and teachers. Many teachers don't know the difference between this, believe it or not. So today I'm going to just kind of share with you what's the essential difference between an average value and an average rate, and how can you tell the two apart on the AP exam. You want to make a little chart for yourself. This will really help you to separate the two ideas. Now be careful, they're not always going to have they're not going to come with the words value and rate. You would think that, well, if they just put the word value there, and I'm always going to know what to do. That's the problem, they don't do that always. Okay, so then it's like, if you just keep using the word average, you are like guessing, like, is it this one or is it the other formula? So first, are you guys good with the two formulas for average value and average rate? Have you seen both of these before? Okay, fine. That's something that this is something we saw in the first week of calc, or second week of calc, and then this is something that we recently saw before the break. Now here's a helpful thing to keep track of. When you're dealing with average value, you'll notice that the units generally stay the same. They don't actually change, okay? So the units stay. I'm just summarizing for you something that is on the board. Now I explained this to you before, but again, this is confusing things, so I'll mention it to you again. Just a moment ago, we were talking about R of T, and R of T was bacteria per hour. So if somebody were to say to you, hey, I want the average value of bacteria per hour, what you would say is, okay, what you're really asking me to do is 1 over the units of time multiplied by bacteria per units of time multiplied by the units of time. So take a look at these units over here. Again, it's the average value formula, but it's not focusing on the numerical end of it, it's focusing on the units of it, okay? So now if you take a look at the units, you'll notice that the units, they initially cross off as you had expected they would, just like I showed you over here, the minutes and the minutes cross off in that previous example. However, here's what happens. This one, being 1 over b minus a, it just basically slides right back in. So your final answer is still going to be bacteria per hour. This is what I mean by the units stay the same. So what you initially had to work with was bacteria per hour. What you get as a final answer is also bacteria per hour. So it's kind of confusing how that works out. On the other hand, let's suppose that you were asked the average rate. All right, so if they ask you the average rate of bacteria per hour, that's going to totally change things. Again, you guys see the formula up there. It says f of b minus f of a over b minus a. But essentially what's going to happen is you'll have bacteria per hour subtracting another bacteria per hour, and that entire thing is divided by b minus a. So the same b minus a is over here, so that's over hours. So what's going to end up happening is the same units, when you subtract the same units, you get the same final units for the numerator. You still have bacteria per hour, and then the denominator is in hours. So this is why oftentimes we'll use the word bacteria per hour, but then because we're physics, we generally make it hours squared. So we say bacteria per hour squared, but it doesn't really, get the point across as well as saying bacteria per hour. So this is what I mean by average rate. The units are going to actually change, okay? All right, now, let's go ahead and take a minute and try this together. Let's suppose that I had a function, all right? I had a function and I had the function's derivative, all right? Let's start with that. And let's suppose I decided that I wanted to take the average value of the function's derivative. All right, now don't look at the board here, just look up here and help me with this. First of all, what would I get if I integrated a derivative of f? I would just get f. Good job, right? The integration of the derivative of f is just going to make it go back one mode, so you'll end up with simply f. So this will look like 1 over b minus a, and now you have f of x, and it's evaluated from the limits a to b. So this is really neat. What ends up happening is you have 1 over b minus a, and this becomes f of b minus f of a, and this becomes f of b minus f of a over b minus a. So let me ask you this. We started off with average value, but what have we ended up with? Average rate. Okay, so you're probably now confused, like, wait, how did that just happen, right? So I want to explain one thing to you. Make sure you write this on your paper. The average value of f derivative is the same as the average rate, but not of f derivative of what? Good job, there you go. So write that down. And I'm telling you right now, most calc professors even wouldn't be able to answer that question. Okay, so I had to sit down in the summer and sort through this. But there you go. If you understand it that way, I don't think you're going to struggle too much now with type of questions that they tend to confuse people with. Basically, the number one confusion that becomes is, should I use this formula or should I use that formula? Okay, and of course they'll always have both wrong answers there. So then you're like, okay, which one am I supposed to use then? Okay, let's go ahead and try one. Okay, so I'll read this for you. It says the temperature in degrees Fahrenheit of a cup of coffee in T minutes after it is poured is given by that equation. So it's a calculator question. And it says to the nearest degree, what is the average temperature of the coffee between 0 and 10 minutes? Okay, so focus on the units, look at what the units are talking about, and go ahead and try this question as well. Right, if you don't know which one to use, you gotta look at the units. The thing that they gave me, what are its units? And the thing that they're asking me, what are its units? If the units are the same, you're using the average value formula. If the units have changed, that must be the average rate formula. This is one of the easiest ways to go about it. These are the last questions, by the way, on the multiple choice. This is question 90 and it goes until 92, by the way. So take your time with this, but take a look at these units. This is what's given. Alright, understand this now, you won't struggle with it later. It says it here, and then it mentions it all in the answer choices. And this is what they're asking. So do you guys think that we're supposed to use the value formula or the rate formula? There you go. You see they didn't change the units on you, right? And nowhere in the question does it mention that. So I had to fish around for something like this to explain it to you. So use the average value formula. And again, in your calculator you should be doing 1 over 10 minus 0 and just integrating that function there. What do you guys get as the answer there?
1.9.
Okay, so the letter D. Cool.
How do we word it if it was asking for average rate? We just what is the rate average?
That's a great question. If they wanted the rate, they would have to say the average rate of the temperature of coffee. They would just have to mention the word rate. And again, it's a great question. I'm trying to think of creative ways that you could do that. But I want to mention one other thing though. What are the units of f of t in this picture? According to the setup. What are
Degrees
they?
Fahrenheit.
Okay. Alright, so watch. Degrees Fahrenheit. Look, it doesn't have a denominator. Okay? What are the units of time in this question? Minutes. So technically, if you were to just integrate this and nothing else, your final answer should be degrees Fahrenheit times minute. Again, that doesn't have a really good application to it. We don't really use things times minutes. We generally use per minute. And now if you look at the answer choices, you'll notice that all of the answer choices have degrees Fahrenheit. So you have to understand that there's something's gotta give. This minute needs to go away. So if you think about what I told you on the board right there, this is units of time. And what are the units of time once again measured in? Minutes. So what ends up happening is you've got these minutes in the denominator, And you've got those minutes in the numerator, so these minutes cancel with those minutes, and that's why your final answer is gonna be degrees Fahrenheit. If for some reason you're even contemplating using the average rate, please realize the average rate would never achieve that for you, so you'd be like, yeah, I'm not gonna use that formula there. We have a few more minutes. This is a free response question. We're gonna try it together. I'm not asking you to do this by yourself. It takes a little bit more thinking on your part. I think it would be a good idea if you put that table though into your notebook when you're gonna be using that part. Today I will be doing letter C with you, but it's possible I may have already done some parts of this with you before. I just don't have a good memory of it, but I think by the end of the year we'll have tackled all the different parts of this question. So you'll definitely get more acquainted with this question as we go on. So as you're making this table, you guys, basically it's a table that's of selected values, and you know what that means. It's not everything that they've given, or everything that happened more like. And there's vehicles that are crossing a bridge. Okay, so there's a bridge, the cars are going over the bridge, essentially. They don't have all the values, they just have the first 12 hours of watching this happen. Now, here's the first most important question. R of t, is that telling you how many vehicles or how fast the vehicles are going over the bridge? Alright, look at the units, it's all about the units, right? How many or how fast?
How fast?
How fast. Okay, so usually the first place where a calc student goes wrong is they thought that at 0 hours there was 2,935 cars on the bridge. That's not what it's saying. That is not what it's saying. It's saying this is how many were moving across that bridge at that hour. When we looked at the 0th hour, this is what we noticed, okay? So in essence, these are derivative values. These are not function values of that sort, okay? And it said that this started at 7 a.m. So from here on out, they're gonna call 7 a.m. t equals 0. So that makes this right here 7 p.m. essentially. And it says values of R of t are given in the table here, okay? Now, I want you to take a minute. I want you to read the question to yourself. And after you've read this question, I want you to sit there and figure out, okay, what am I supposed to do to answer this question over here? This is a calculator question, so you can definitely use a calculator to kind of go through this. You have about 3 or 4 minutes. I encourage you, please do not take wild guesses with this, okay? So, first thing I notice is H of T is not R of T. It's just modeling the data from R of T. They do this all the time. They give you a table and they say, by the way, here's an equation that models this really well. So now you just totally ditch the table and you just stick with the equation after that. The equation, however, is still measuring things in vehicles per hour, so it's still a rate, alright? And then you're like, okay, now you want the question is also asking for vehicles per hour. So that's where you are going to go ahead and use the average value theorem. And once you use the average value theorem, what's the answer that you guys got for this?
2,452.
Exactly?
Yeah.
What are the units?
Vehicles per hour.
There you go, which is vehicles per hour.
Hold on, so if you said like the whole thing, like 2,452 average number of vehicles constantly per hour, is that still fine or do they want to?
No, it works the same.
So this is kind of a random question, but why is the RT and then HT, why did it switch it?
Because this is, once again, a 4-part question, right? This is letter C. So they gave you a table, but it happens all the time. You learn this in statistics is, they'll give you a table, but then they'll say, by the way, this model here, this line here, it presents the same exact data or close to it. So then you ditch the table and you use the equation. Yes?
So if it was a question and let us see average rate, would they have told us like, gave us something about the hours and asked about minutes?
Yes, they would have to say per hour squared in order to achieve that. We'll come back to this, I think. 1, 2, yeah, I think, you probably have something for the weekend. So tomorrow's Friday, right? Tomorrow when we get back, we'll continue inshallah. Don't forget to bring your homework in. That's not a problem at all. Whatever I can do. Inshallah, keep me in your du'as. How are you?
Now we have all these.
Oh, yeah.